Hi class, here is a helpful video, I hope, of the homework for January 10th, 6.1 Polygon Angles Day 2. I'm going to do a number of these. Some of these we did in class, so this might be a repeat for you. And I did post an answer key with a lot of the problems worked out. What I'm basically going to do, though, is just show you how to do a few in each section so that you can figure out how to do it from there. I don't want to do them all. I want to give you the chance to practice. So I'm not going to answer number 1 until class time, maybe. I want you to think about that one. But number 2, find the measure of each exterior angle in a regular polygon. Okay, so we're going to find the measure of each exterior angle. Remember, exterior angles add up to 360. So if we have 360 degrees divided by 3, that will tell us how much each angle will be. So 360 divided by 3 is 120. We're using this formula. N times E equals 360. The number of sides times the exterior angle equals 360 degrees. In this case, we're going to solve for E. So E equals 360 divided by N. So this is the actual form of the equation we're going to use. So we just take 360, I'll do letter D. We take 360, that's how many degrees the exterior angles have. And it's a regular polygon, so if we divide by 6, we can see that each angle is 60 degrees. And you're going to do the same thing for B, C, E, and F. I'll do F. You take 360 degrees, and we divide it by 10 sides. 10 sides means 10 angles. 10 interior angles, and it also has 10 exterior angles. So if we divide 360 by the 10 exterior angles, that tells us that each angle is 36 degrees. This is of a regular polygon. Okay, now in number 3, we're going to find the measure of each interior angle in all these regular polygons. So if we have a regular polygon with 3 sides, and the exterior angle is 120, then the interior angle is going to be 180 minus 120. Here's the interior angle right here of 120, and here's the exterior angle right here. Oh wait, let me pause that for a second and restate that. Hold on a sec. Okay, so the exterior angle is 120. And so the interior angle is going to be, I'm just going to redo this. The exterior angle is 120. And so the interior angle, that's the angle we're trying to find, is going to be 180 minus 120. So let's look at B. When we do, or let's look at, B. Okay, so 4 side figures. If we take 360 and divide it by 4, each angle on the exterior is 90 degrees. Okay, so I'm just going to draw the picture. Here we have a square because it's 4-sided and all the sides are regular. Okay, it's a regular polygon. So the exterior angle was 90. We found that out in number 2. Now we can just look for this interior angle here. It's going to be 180 minus 90. These are a linear pair. So they are going, this is a linear pair, so they're going to be supplementary. So the interior angle here is 90 degrees. Okay, so when we look at letter D, here we have a hexagon. I'll draw one as best I can. That's a regular hexagon. All the sides and all the angles are congruent. So here's a hexagon. And the exterior angle was 60, because we took 360 and divided by 6. Well, the interior angle is going to be 180 minus that. So that's going to be 120. Okay, so for letter F, here we have a 10-sided figure. I'm not going to try to draw it. But the interior angle is, the exterior angle is 36 degrees. So the interior angle is going to be 180 minus 36. That's going to be 144 degrees. This is very simple. Once you've found the exterior angle of a 4-sided regular polygon, then you just subtract it from 180, and that's going to be the interior angle. Number 4, find the number of sides of each regular polygon. Notice the keyword regular and notice the keyword exterior. So that means we're going to use this equation of n times e equals 360. And we're looking for the number of sides, so we want to solve for n. So n equals 360 over e. So for each of these, A, B, C, and D, we just take 360 and divide it by the measure of the exterior angle, and that will tell us the number of sides. So 360 divided by 9 is going to be 40. So there's 40 sides. Okay, I'll do letter C. Here we're told that each exterior angle is 30 degrees, so we take n equals 360 divided by 30, and that becomes 12. So our number of sides is 12. That's what we learned today about these exterior angles, that the sum is 360 and that the interior angle will be supplementary to the exterior angle at that vertex. All right, number 5 is what we learned on Wednesday. Find the measures of each interior angle by using this and then dividing. Okay, so here we have a 16-sided figure. And we want to find what the measure of each interior angle is in a regular polygon. So the first thing we do is find the sum of the interior angles, and that's using the formula S sub I equals n minus 2 times 180. So first we're going to find the sum of all the angles. So the sum of all the angles is 16 minus 2 times 180. That equals 14 times 180. That equals 20. And you can use your calculator, 2520. All right, so that is the interior angle sum. This is using this formula. Remember, the exterior angle sum is going to be 360. But the interior angle sum, you have to use this formula where you subtract the number of sides, you subtract 2 from the number of sides, and that's how many triangles you get, and multiply that times 180. So here's our interior triangle sum. Now we want to know how much is each angle inside. Well, it's a 16-sided figure, so it has 16 angles. So each angle then would be 2520 divided by 16, and that is, put that in your calculator, is 157.5 degrees. So each interior angle in a 16-gon is going to be 157 degrees. It's 2 steps. The first step is to find the interior angle sum, and then you divide. So this is step 2. And you divide by the number of to see how much each angle is. Okay. Next one. I'll do 30. The interior angle sum will be 30 minus 2 times 180. So that is 28 times 180. And that is, let me get my calculator. 28 times 180 is 5040, so 5,040. All right, that's the sum of all the angles inside. But since it's a regular polygon, each angle is going to be the same measure. So I'm going to take 5040 and divide by 30, and that becomes 168. So each angle inside is 168. So now you follow the same exact process. First you find the interior angle sum of the gon, whether it's a 36 gon or a decagon, and then you divide that by 10 to see how much each angle is. Okay. Number 6. I'm going to do A and C, and you're going to do B and D. So use an unfinished gon sketch to find the number of sides that a regular polygon has. We don't have to use it for A here. So A and B, we don't need to use this sketch. We're going to use this fact and this fact. Actually, I think we're going to use just this fact. So each exterior angle is 40 degrees. Well, I mean, I could sketch it. Here's my polygon, my unfinished gon. And here's the exterior angle is 40. Well, if I want to know how many sides this has, remember we use the formula n times e equals 360. So if I want to know the number of sides, n equals 360 divided by E. So the number of sides is going to be 360 divided by 40. And so that's 9 sides. And you're going to use that same process here, where you're trying to find the number of sides. So it's 360 divided by that exterior angle. And that will tell you the number of sides. This is a little trickier. This is when we really want to use the sketch. So here I'll make a sketch. Here's my unfinished Polygon. And the interior angle is 150 degrees. And remember, these are all regular polygons. So every angle is going to be 150. So if this angle is 150, remember, these are supplementary. So the exterior angle is 30. So if I want to find the number of sides, I can just take 360 and divide by 30. And that's equal to 12. So slow it down, speed it up, watch it again. But the trick here is when you're given one angle, an interior or exterior angle, if you're giving an exterior angle, you can just divide 360 by that and you'll get the number of sides. If you're giving it an interior angle, then find the exterior angle and do the same thing, 36 divided by that angle. It's a lot easier than trying to solve it with the interior angle. So you're going to do the same process here as we just did here. Number 7, find the sum of the interior angles of a 52-gon. This is just using SI equals n minus 2 times 180. We're finding the interior angle sum. So that means it's 52 minus 2 times 180. And that means it's 50 times 180, which is equal to 9,000. So the interior angle sum of a 52-gon is 9,000. How many sides does a polygon have if its interior angle sum is this many, or this many? I'm just going to do B. Wait, which one did I do on the answer key? I did A, okay, let's see. I did A and B on the answer key, so I'll go ahead and do B here, and you can look at the answer key for A. But 9,000 is the interior angle sum. Okay, let me say that again. So we have 9,000 is the interior angle sum. So 9,000 equals n minus 2 times 180. So what we're going to do now is we're using the same formula we used up here, but here we were given the number of sides. Here we're given the sum, so we got to solve for the number of sides. So we can distribute, or we can divide by 180. We're going to divide by 180. I'm dividing both sides by 180. So that will cancel. And 9,000 divided by 180 is 50. So we get 50 equals n minus 2. If we add 2 to both sides, we get n equals 52. Okay, so we have, and that's actually the answer from here. If we have a 52-gon, the interior angle sum is 9,000. If we're given that the interior angle sum is 9,000, if we solve it the other way, we'll find out that n equals 52. And the way you would solve this one is the same. You'd set up 900 equals n minus 2 times 180 and solve for n. The hint I'm going to give here is if the interior angle sum is equal to its exterior angle sum. Okay, the exterior angle sum is always going to be 360. So that means that the interior angle sum is equal to that, so it's 360. So you set up your equation. 360 degrees equals n minus 2 times 180, and now you solve that for n. Okay, so I'll leave that for you to solve. That one, we already solved this one, so you're going to solve that one and solve that one for the number of sides. And I'll let you do number 9. This should say interior angle sum. If it's interior angle sum. Okay, now these problems here, I want you to be careful because notice that all of these angles are on the inside of the polygon. So if we're trying to solve for x, we need to use the interior angle sum formula. Now these are exterior angles, so these all have to add up to 360, right? Because these are outside the polygon. These are inside the polygon, so we need to first solve for the interior angle sum and then make an equation to solve for x. And again, here we have interior angles. So we have to use this first to come up with, the interior angle sum and then set up an equation. And this is kind of a mix of things. So, and so is this. So let's look at 10. There's 1, 2, 3, 4, 5 sides. So this becomes 3 times 180, right? 5 minus 2 is 3. This becomes 540. So we know that these interior angles are equal to 540. So I can set up an equation now. 90 degrees plus 90 degrees plus 90 degrees, right? These are all 90, plus x, that's 2 x's, equals 540. So we have to make sure we're adding up the interior angles first to 540, and then we can make the equation. This is 270 equals plus 2x equals 540, and we keep solving this equation. We subtract 270 from both sides, and we get 2x equals 270. Now we can divide both sides by 2, and we get x equals 135. So that's going to be 135, and that one's going to be 135. Now I'll let you set up the equation and solve this one. You just add up 52 plus 2x plus 88 plus x plus 10 plus x plus 2, and it should equal 360. Okay, so in letter C, again we have an interior angle. So we're going to solve for that interior angle first. Actually, we could solve for the exterior angle first. That's a little faster. This is a regular pentagon. So if we want to know what the exterior angle is, then the exterior angle equals 360 divided by the number of sides, which is 5. So this exterior angle is going to be equal to 360 divided by 5. So that is 72. So our exterior angle is 72. So y equals 72. Now this is a regular pentagon, so all of the exterior angles are 72. And all the interior angles are going to be the same also. So we know that if this is 72, this has to add up to 180. These two have to add up to 180. So x equals 180 minus 72. And that means it equals 108. So we've solved for x and we've solved for y. Okay, letter D, find the interior angle sum here by using the number of sides, which is 1, 2, 3, 4, 5, 6, 7. So we'll use 7 in here and solve this for, or evaluate this for the interior angle sum. And then make your equation. So whatever this is, you have 100 plus 100 plus 100 plus 1, 2, 3, 4 plus 4x should equal whatever that interior angle sum is. And then solve that equation. Oops. Okay, again on letter E, all of these angles are inside, so once we find out what the interior angle sum is, we're going to add these up. And notice I put a Y on here. This is an angle inside. So this is a 1, 2, 3, 4, 5. This is a 5-sided figure, so it's going to be 5 minus 2 times 180. That's 3 times 180. That's 540. Okay, so it's 540 degrees. So that means that 90 plus 80 plus 90 plus 70 plus this interior angle y has to equal 540. Okay, so we're going to solve this for y. So this is 180, 260, 330. 30 plus y equals 540. So now we subtract 330 and we get y equals 210. So this inside angle is 210. Okay, because we added up all these angles, and they have to equal 540, because this is a pentagon, a concave pentagon. Okay, this is a concave pentagon. And the interior angle sum formula works for the interior angles and concave pentagons. All right, so we know that y is 210. Well, this whole angle has to measure 360. So to find x, you just take 360 and minus 210, and you get 150. So x equals 150. On f, you need to find this angle, find out what that is, and then, I don't know if I should call it x. Find this angle, and then then find, how would you do this one? Oh, so you find this angle, and then all four of these angles have to add up to 360. I'm going to let you play with that one, okay? It's a challenge question for sure. Okay. And last, I'm just going to draw an equilateral but not equiangular quadrilateral. So that's four sides. So equilateral but not equiangular. So I'm going to draw a rhombus. All of these sides are the same length, but the angles are not the same. And here we have it's equiangular but not equilateral. So all the angles, I'm going to make all the angles be 90. That's 90, that's 90, that's 90, that's 90. So these angles are all the same, but this side is longer than this side. So this is equiangular, but not equilateral. And then you should have these in your notes, these names, and you should have them memorized. Nonagon, septagon, or heptagon. Either one. Octagon, hexagon, and a quadrilateral. Okay, I ran through these pretty quickly. I'm running out of time, so I thought I'd just get something down. Maybe it'll help. We'll keep working on these polygon angles in the next class. Okay, have a nice day.